Hi, let's talk about lubrications. Before discussing lubrications and wear mechanisms, some information about lubricants is necessary. For example, what are lubricants made of and what are their properties? Are oils different from grease? Can mineral oils be used in high-performance engines? Which oils are most suitable for application to gears, bearings, etc.? What criteria should they meet? What is the oil viscosity index, pressure viscosity coefficients? How can these parameters be determined? What are the thermal properties and temperature characteristics of lubricants? An engineer should know the answers to all of these questions. In simple terms, the function of a lubricant is to control friction and wear in a given system. The basic requirements therefore relate to the performance of the lubricant, such as its influence upon friction and wear characteristics of a system. Another important aspect is the lubricant quality, which reflects its resistance to degradation in service. Most of the present-day lubricant research is dedicated to the study, prevention and monitoring of oil degradation, since the lifetime of an oil is important as its initial level of performance. Apart from suffering degradation in service, which may cause damage to the operating machinery, an oil may cause corrosion of contacting surfaces. The oil quality, however, is not the only consideration. Economic considerations are also important. For example, in large machinery holding several thousand liters of lubricating oil, the cost of the oils can be very high. The parameter which plays a fundamental role in lubrication is oil viscosity. Different oils exhibit different viscosity. In addition, oil viscosity changes with temperature, shear rate, and pressure, and the thickness of the generated oil film is usually proportional to it. So, at first glance it appears that the more viscous oil would give better performance, since the generated films would be thicker, and a better separation of the two surfaces in contact would be achieved. This unfortunately is not always the case, since more viscous oil requires more power to be sheared. Consequently, the power losses are higher, and more heat is generated, resulting in a substantial increase in the temperature of the contacting surfaces, which may lead to the failure of the component. For engineering applications, the oil viscosity is usually chosen to give optimum performance at the required temperature. Knowing the temperature at which the oil is expected to operate is critical, as oil viscosity is extremely temperature dependent. The oil viscosity of different oil varies at different rate with temperature. It can also be affected by the velocity of the operating surfaces. The knowledge of the viscosity characteristic of a lubricant is therefore very important in the design and in the prediction of the behavior of a lubricated mechanical system. Thanks for watching.